Hello, we are civil tailing consultants, and for our senior design, we were tasked with the analysis of tailing dam failures. Tailings, such an essential part of our world, yet unknown about in society. Well, this was until recently. So what are mine tailings, and why are they becoming such an issue around the world? Tailings are the byproduct of mining and consist of waste materials left after the desired mineral is extracted from ore. They are a mixture of crushed rock, water, and quantities of minerals, such as copper, mercury, zinc, etc. Because there is no sustainable nor economical way to separate the water from tailings, engineers build dams to contain tailings from minings. Unfortunately, tailings storage facilities are complex and can be prone to catastrophic failures that can have devastating impacts to infrastructure downstream. Many of these failures are still yet to be fully understood. Our job was to design and evaluate the stability of an embankment dam that would be used to retain tailings and show that the slope was stable before overtopping failure. We chose to conduct our analysis on the most common dam type and dam failure, which is an upstream dam with an overtopping failure mechanism. We utilized GeoStudios and Flow3D for our computational analysis.
The first step in our analysis was to look at the reports from other tailing storage facilities to get the material strength parameters for each material. And then next we looked at the geometry, and we had a few iterations before we arrived on our final design.
Yeah, so once we arrived at that final design, we ran a stability analysis on it in GeoStudio to ensure that the factor of safety was above 1. And after we ensured that, we began in GeoStudio carving out parts of the dam face itself to where the factor of safety was below 1 to show overtopping failure.
For the tailings runoff analysis, Julie and I used Flow3D to model the tailings flow path during an upstream dam failure. The importance of this piece is to provide adequate representation of overtopping failure and how tailings will flow downstream.
To begin our model, a replica of our dam was created in SolidWorks, then imported into Flow3D. From there, we created a proper real-time simulation and entered real tailings parameters. This provides us a realistic model of our dam failure.
Being environmentally conscious and with sustainability in mind, a 30-centimeter physical model was created using reused supplies and tailings from past experiments.
Creating the tailings dam layer by layer allowed us to simulate the creation of a real tailings dam. As the dam failed, we were able to see our prediction and model of the failure come to life. This helped in our decision making for the 200 by 20 by 8 sized flume for the full-sized model to be created at the Engineering Research Center. Working together as a team, everyone's strengths are utilized to bring together an optimal design result. So come see us at Edays on April 24th in the Lory Student Center Grand Ballroom. And feel free to send us any questions you might have prior to the event using our QR code so we may provide you with a thorough response. Thank you for taking time to learn more about engineering solutions around the world. We look forward to seeing you on April 24th.